Hi, my name is Ranjit Wadikar. Today I'll be presenting you with my final assignment of Coursera on machine learning for project manager. In this assignment, we'll be predicting the electrical energy output of a combined cycle power plant, which uses a combination of gas turbines, steam turbines, and heat recovery steam generator to generate power. We have been provided a data set of nearly 9,568 hourly average ambient environment reading from the sensors at the power plant for modeling. Our data set does not have any null values. Our data set values are of floating data type, and data is related to ambient temperature, ambient pressure, relative humidity, exhaust vacuum, and target net hourly electrical energy output. Here is a sample of few records from dataset provided for our assignment. This shows data value where ambient temperature is aliased as AT, exhaust pressure aliased as AP, exhaust vacuum aliased as V, relative humidity aliased as RH, and target energy output aliased as PE. Considering 9,568 dataset records, here we can see statistics of the data like count, mean, STD, etc. From the dataset, as we have evaluated to check null values in dataset and no null value is available in the provided dataset. Here, as you can observe that we have evaluated to check that data is of floating data type. Now we have to decide on type of machine learning algorithm to use. As our dataset consists of numerical values which are like sensor reading and power energy output, we will use regression for our modeling purpose. Here we cannot use classification because this is not a classification problem. Here we are going to attempt to fit models such as linear regression, ridge regression, lasso regression, polynomial regression with and without k-fold validation, and access which of this model fits best to our dataset. As there is a strong correlation between each of the input variables and output variables, and so we will use all the variables for our evaluation purpose. The matrix we are going to use is mean square error matrix, and we will see in the next slide that there aren't too many outliers in the data for each of these values. So let's move to the next slide. Here is a paragrid of all the variables with each other, and we do not see too many outliers as discussed. Now, next step we have to do is split our data set. As our data set is small, we will use 90% of our data for training and 10% for testing. So preparing our data set, we see that we loaded our data set into full underscore df data set. Now we will split full underscore df data set into feature and label dataset, and then we are going to split the dataset into train feature, test features, train label, and test labels. And here we are splitting test size as 10%. Here we have linear regression, which when evaluated, linear regression used in MSc is 20.9223 and furthermore decimal values. The next model what we evaluated is linear regression model with k-fold validation. So in this we will be using a validation set within our training set and have and split for the k-fold. So doing that we see that the MSc is 20.947745 and a few more decimal values ahead. So which is still very close to what we saw in linear regression. Next, we tried ridge regression model and checked the MSc. Regression model MSc we see is 20.9223 and a few decimals ahead, which is slightly lower than what we see in previous two cases. Let's see regression model with k-fold validation and check the MSc. This seems to evaluate MSc as 20.947745 and few more decimal values ahead, which is similar to MSc, which we saw in linear regression model with k-fold validation. Now let's try lasso regression model with k-fold validation. Here we observe that the MSc is 20.948365 and few more decimals ahead. Going ahead, we have tried a polynomial regression model. So Using some research, we found that degree 8 has some least MSC. So we will try to build polynomial regression model with degree 8. So here MSC what we has been evaluated is 14.35917 and few more decimals ahead. Going to the next slide, we will understand how using degree 8 polynomial regression model will result in best MSC value. So here we went to each degree between 1 to 9 and evaluated the MSC. So here are the different MSC we get as we increase the degree of polynomial. So if we see MSC keeps going down until degree 8 and then from degree 9 it starts having backup. One thing we might observe here is that MSC polynomial regression without k-fold is using a much lower MSC value compared to using MSC polynomial regression with k-fold. We can play around with hyperparameter of how larger text and train set has to be or how larger k-fold set has to be. As such, this is a good indication that degree 8 polynomial regression model is the best of all model we have seen so far. Here we have printed out all the MSC values. So you can see that the MSC value for linear without k-fold is 20.92 and few more decimals value ahead. Linear regression with k-fold has the value of 20.9477 and few more decimal values ahead. Linear regression has a MSC value of 20.9223 and few more decimal values ahead. Linear regression with k-fold has 20.947745 and few more decimal values ahead. And linear lasso with k-fold has MSC value of 20.9483 and few more decimal values ahead. So here as we see the polynomial regression with k-fold, when compared, the minimum MSC what we got is 16.646677 and few more decimal values ahead. This is the minimum MSC value what we get, which is in degree 8. Like as you can see here, from degree 1 to degree 8, all the MSC values are going on the lower side. But as soon as the degree 9 is coming in picture, that value is going up. So we can consider that degree 8 is the best MSC in polynomial regression. So considering the same thing, when we checked the polynomial regression with without k-fold, the degree 8 MSC value fetch 14.3591 and few more decimal values ahead. So we observed that because polynomial regression with degree 8 has the lowest MSC, we will use this model for our prediction model. Thank you for listening to my assignment. Goodbye.